multiplicities of zeros of polynomial functions. Our objective, we want to identify real number zeros and their multiplicities and identify how this affects the graph of the polynomial. So what do we know that we're going to find useful for this lesson? We know what a polynomial function is. We know what real numbers are, specifically the set of all numbers that appear on the number line. Since we're talking about graphing, our number line will be the x-axis. We know that the degree of the polynomial is equal to the number of solutions or roots or zeros as long as we count multiples separately. And we know what factoring is. Okay, as far as a polynomial is concerned, we want to write a polynomial as a product of factors. And how do we factor? Well, some ways of factoring are greatest common factor, grouping, trinomials, difference of squares, etc. And factoring, along with a zero product property, is a method for finding a function's solutions. So, what is multiplicity? Multiplicity is how often a certain zero is part of the factoring, or how often a certain factor occurs. For example, I have here a factored sixth degree polynomial. Okay, now let's remind ourselves, if it's a sixth degree polynomial, we know that we have 6 solutions or 6 zeros if we count multiple zeros separately. If we look here, the way we solve these things is we set them equal to 0, and we can see that if a times b times c equals 0, then a equals 0, or b equals 0, or c equals 0. So if x equals 5, this is 0. If x equals -7, this is 0. And if x equals +1, this is 0. So our zeros are 5, -7, and 1, and those are all real numbers. Because they're real numbers, they're on the number line, which as far as we're concerned means they are on the x-axis, and they're also called x-intercepts. Now if we expand this, write this factor out 3 times, write this factor out once, write this factor out twice, we get this. And again, we can now see that x equals 5, or x equals 5, or x equals 5, or x equals -7 from this factor, or x equals +1 from this factor, or x equals +1 from this factor. And again, 1, 2, 3, 4, 5, 6. 6th degree polynomial, 6 zeros if we count multiple zeros separately. Okay, we can now compare the exponent, the number of times the 0 occurs, with its multiplicity. So the 5 occurs 3 times, therefore it has multiplicity 3. The exponent being 3 right up here. The -7 occurs 1 time, and there's an exponent right there of a 1. We don't usually write a 1 exponent, but there's always 1 there. So the -7 occurs once. It has multiplicity of 1. The 1 occurs twice. Okay, there's the 2 exponent for the 2 occurrences. Therefore, the 0 of 1 has multiplicity 2. Okay, so what does all this mean? Okay, now we know what multiplicity is and how to find it. What does it mean? Okay, give me just a second to get my notes arranged. The multiplicity of a real number 0 tells us whether the graph of the polynomial touches the x-axis at the 0 and turns around, or crosses the x-axis at the 0. It will do one or the other. Okay, all of our real number zeros are x-intercepts, so the graph will either touch it and turn around, or it will cross it. Well, how do we know? Well, if it's even multiplicity, it touches the x-axis and turns around. Okay, even multiplicity means that that 0 occurs 2 times, 4 times, 6 times, etc. If the multiplicity is odd, that means that that 0, the graph will cross the x-axis. And of course, odd multiplicity means the 0 occurs 1 time, 3 times, 5 times, etc. Let's take a look at some examples. Lots of words in there and some vocabulary. It's nice to kind of see how it really works and see some examples to kind of help it get into your brain a little bit. So we want to find the zeros of this function. Notice it's already factored. And we want to give the multiplicity of each 0. We want to state whether the graph crosses the x-axis or touches the x-axis and turns around at each 0. And we want to check our answer. We want to see our answer using our graph. So we know we need to set this equal to 0. So I'm going to rewrite this polynomial function, and I'm going to set it equal to 0. Okay, now I know that if A times B times C equals 0, then A is 0, well, it's not, or B is 0, and it can be, or C is 0 in order for that to be true. Well, for this part to be 0, x would need to equal -1/2, and for this factor to be 0, x would equal 5. Okay, so we have 2 unique zeros, and they are at x equals -1/2 and x equals 5. So we have 2 x-intercepts. One of those is at -1/2, one of those is at 5. Okay, so let's write those zeros down over here, -1/2 and 5. And then let's write down next to them what their multiplicities are. Well, -1/2 occurs twice, so its multiplicity is 2. 5 occurs 3 times, its multiplicity is 3. Okay, so now what is the effect on the graph at each 0, at each x-intercept? Well, at -1/2, we have even multiplicity. We go up to here, and that tells us that the graph will touch the x-axis at -1/2 and then turn around. So we'll make a note of that. Graph touches x-axis at x equals -1/2 and turns around. Okay, at our 0 of 5 has multiplicity 3. That's an odd number. Come back up to here. If a 0 has odd multiplicity, the graph simply crosses the x-axis at that 0 or at that x-intercept. Okay, so we'll make a note of that here. The effect on the graph of the multiplicity of 3, the graph crosses the x-axis at x equals 5. Let's take a look. See if that's really true. Make sure I get the function in there so we can see. I'm going to graph this function right here. So allow me to get my calculator together. I'll go to I'll go to my y equals. I got another function in there. I'll clear that one out. -4 times x. I'll put in 1/2 as 0.5, a little easier, squared, times x minus 5 raised to the 3rd power. And I'm going to go to my standard window and see what it looks like. Okay, so, well, I can clearly see that at 5 here, the graph is crossing the x-axis. That's pretty good. Looks like I'm zoomed a little bit too far out for the pixels to come in and pick this one up. So let's zoom in over here and get that graph to touch. I think we need to zoom in to see that. So I'm going to zoom in pretty closely. I know it is at -1/2. So I'm going to zoom in from, whoops, let me go to window. I'm going to go from -1 to 0. That's a pretty tight zoom in, and I'll count by halves. And my y, I'll go from -1 to 1. I've really zoomed in. And there you go. So now you can see the graph coming down, touching at -1/2, and then going back off. So there's your even multiplicity, where the graph comes in and touches and turns around, touches the x-axis. Okay, so we saw on the graph. Let's remind ourselves of a final thing. It is a 5th degree polynomial, which means we have 5 zeros if multiple zeros are counted separately. Okay, well, our 0 of x equals -1/2 takes place 2 times. Okay, here it is, that's multiplicity 2. Our 0 of x equals 5 takes place 3 times. 5 has multiplicity 3. And if I add those two numbers up, I get 5. 5 solutions. Whoops, a little bit too low there for you. 5 solutions if multiple zeros are counted separately for a 5th degree polynomial. The degree and the number of solutions always match up. All right. Let's take a look at 2 more examples. We'll do the next one with just a little bit of factoring. Okay, example number 2. Find the zeros of this 3rd degree polynomial, x cubed minus 2x squared plus x, and give the, whoops, just a moment, let me get my papers together, yep, and give the multiplicity of each zero, state whether the graph crosses the x-axis or touches the x-axis and turns around. Check your answer with your graphing device. So the first thing to do to find zeros is we set that equal to 0. This has a common factor of x, so let's factor that out. We're left with x squared minus 2x plus 1 equals 0. Well, this is a quadratic, and that one factors as x minus 1 times x minus 1 equals 0. So we have 3 solutions, x equals 0, or x equals 1, or x equals 1. Okay, 3 solutions. Again, it's a 3rd degree polynomial. I will have 3 solutions as long as we count our multiples separately. Okay, let's take a look at our zeros and their multiplicities and the effect on the graph. Okay, we'll have a 0 at 0. It takes place 1 time, multiplicity of 1. Therefore, the graph crosses the x-axis at x equals 0. It crosses the x-axis at this intercept. The other 0 is 1. It has multiplicity 2. There's our 3 of our 3rd degree. Because the multiplicity is even, the graph touches the x-axis at x equals 1 and turns around. Okay, let's take a look at that. See if that's true or not. Okay, I'm going to be graphing this polynomial right up here at the top. Okay, back into y equals. Clear what I had in there. X cubed minus 2, and I need to be careful. I make mistakes sometimes, and it throws me. plus x, and I'm going to go back to my standard window. And there it is. And you can see the action's going on in the middle here, whether it crosses or touches. So let's zoom in there. I will zoom in this time. I think I can get in close enough. I want to be right in here. Okay, there you go. You can see it. It is crossing at 0 right there. It's going above the x-axis, coming down, hitting at 1, and turning around. And that's what we have here. It crosses at x equals 0. There's the cross. It touches at x equals 1 and turns around. There we go. Okay, last example. We're just going to use the graph to tell us what's happening. Okay, so example 3. Use the graph to find the real number zeros of this 4th degree polynomial, x to the 4th minus 4x cubed minus 12x squared plus 32x plus 64. Whew, mouthful. And to determine the multiplicity of each of these zeros. Well, it is a 4th degree polynomial, which means it has 4 zeros total if we count multiple zeros separately. Let's use the graph. Y equals clear, x to the 4th power minus 4x to the 3rd power minus 12x to the 2nd power plus 32x to the 1st power plus 64. Let's zoom in and do my graph in the standard window. And here we have it. Okay, so this graph looks interesting. I'm hitting 2 x-intercepts and both of them are turning around. Let me see if I can get the top of this so you can see it a bit better. So I need to go from -5 to 5, I think, and then I'll go higher. Window, how about from -5 to 5? But I need more height, so I'll go from -2. Let's try 30 and let's try 30 and see if this helps us get the whole graph in there. It might not. Nope, not quite. I gotta go a little bit higher. Perhaps a lot higher. Well, I won't go any more, but it's coming down from here. It's touching the x-axis here. It's going back up to here someplace, coming back down and touching the x-axis here. So I have 2 real zeros. You can probably see them here. There's one at -2, and there's one here at 4. I can go to my table, and you can see here the 0 at -2, and here the 0 down here is at 4. Or you can go to the graph and press calc and find your zeros this way. Okay, but I know I have, so my zeros are at -2 and +4. Okay, let's talk about the graph. The graph at -2, touch and turn. The graph at 4 is touch and turn. Okay, so what is the multiplicity? Well, I have 4 zeros total. These are both even because they touch and they turn, so they are a minimum of 2. Well, that means they're both 2 because I have 4 total. Since they both are x-intercepts and they both are even because they touch and turn, they both have multiplicity that's even. And the only way they can both happen and have a 4th degree is that they both have multiplicity of 2. So there you have it. Lots of work on graphs, multiplicity, and number of zeros equaling the degree of the polynomial.